Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for October-November 2022, and the code is 9709/62. Alright, so let's start. Now, first question, each of a random sample of 80 adults gave an estimate H meters of the height of a particular building. The results were summarized as follows. The n equals to 80, summation h equals to 2048, and summation h squared equals to 52760. Now A, calculate unbiased estimates for the population mean and variance. So for your information, the unbiased estimates of the population mean is x bar. So the x bar is summation h over n. Alright, so replace the values of these two unknowns. I would say these two parameters, then I will get 2048 divided by 80, and then you'll be getting 25.6. Alright, so done for the population mean. Then now estimate unbiased estimates for the variance. Population variance will be sigma h squared. And this is also same as the s squared, which is our sample variance. Formula is 1 over n minus 1 multiplied by summation h squared minus square of summation h then over n. Right? So now replace the values. 1 over, the n is 80, so 80 minus 1 becomes 49. Then now summation h squared will be 52760 minus square of 2048 then divided by 80. So at last we will be getting 4.19. So that's the solution for the part A. Okay, now part B. Using this sample, the upper boundary of an alpha % confidence interval for the population mean is 26.0. So this 26.0 is the upper boundary. Now we need to find the alpha value. Okay, so now for your information, alpha % confidence interval for mu is x bar plus minus z alpha over 2 sigma. Now we use sigma h here because from the first part it is unknown. So we have estimated it in the part A. But then the question says upper boundary. So from here I will say that the upper boundary of the confidence interval, it will be the plus. Okay, so x bar plus z alpha over 2 sigma hat over square root n. And now it's given that the upper boundary is 26.0. So by replacing the x bar and the sigma hats from the part A, so x bar will be 25.6. The z is unknown now because the alpha value is not given. Then sigma hats will be square root of the 4.19, right? Because it's a square root of variance. So 4.19 over 80. Right, so from here, by moving the 25.6 to the left hand side and divide by this square root, I will be getting the z value. So my z alpha value, alpha over 2, is going to be 26.0 minus 25.6 divided by the whole square root. Right, and then from here, you'll be getting 1.748. Correct, so three decimal places, so that we can read it from the table. So now when you refer to table, okay, let me draw the graph here. Right, so the z alpha over 2 is 1.748. That means that is the critical value. So here is 1.748. Okay, now from the table, okay, from z table or the normal table, then we know that p z less than 1.748 is going to be 0.9598, which means all this will be 0.9598. But then you must understand that for the confidence interval, it should be two-sided, right? So two-sided test. That means the other side will be negative 1.748. So from here, I know that this value, the upper tail, right, is going to be 1 minus 0.9598. So Pz more than 1.748 is going to be 1 minus 0.9598. Then it will be 0.0402. Okay, which means the green region is 0.0402, which means this left-hand side, the green region is the same. Okay, so now in order to get the middle region, it's going to be 0.9598 minus the left region. That is our alpha value. Okay, 1 minus alpha value. So here I will say my alpha is going to be, okay, because normally here is 95% or whatever. So now I will just minus to get the alpha value. Alright, so now my alpha value is going to be 0.9598 minus 0.0402 times 100%. So from here, when you minus and times, at last you'll get 91.96%. And we need to give our answer equal to 3 significant figures, which means it will be 92.0%. Okay, which means your alpha is 92.0. Alright, so that's all for this solution. Okay, now question 2. In the past, the mean length of a particular variety of worm has been 10.3 centimeters with standard deviation 2.6 centimeters. Following a change in the climate, it is thought that the mean length of this variety of worm has decreased. Right. So now the length of the samples, random sample of 100 worms of this variety are found, and the mean of this sample is going to be 9.8 centimeters. Okay, so these are the important measurements. So assuming that the standard deviation remains at 2.6 centimeters, carry out a test at 2% significant level of whether the mean length has decreased. Okay, so this is the hypothesis testing regarding the mean length. So now your H naught mu equals to 10.3. Okay, because it's mentioned here 10.3. And now you are testing whether it has decreased. So therefore, your H1 will be mu less than 10.3. Right? Alpha is 2%, 0.02. Here is 2%. So now from here, since your worm, the sample size is large, which is 100. Alright? And then even though, now basically when you refer to the first sentence, alright? So when you look at the standard deviation 2.6, so it means that the population standard deviation is given, means that we are going to use normal test, right? So for this case, I will just draw the graph first to get our rejection region. So since this is less than 0, I mean less than 10.3 for the H1, that means this is lower tail test, one tail test, right? So my alpha is 0.02. But then when you refer to the table, the Z table, the critical value should be positive. That's why I flip it to the right side, and I know that the green region is going to be 0.02. So now, when here is 0.02, that means the region towards the left-hand side will be 0.98. Okay, so now you read the table. When it is 0.98, the critical value is going to be 2.054. So here is going to be 2.054. Then minus, because my actual region is on the left side. Okay, so you may label the right hand side as 2.054, but remember our original region is on the left hand side. So after this, just write down the critical region H naught if the Z value that you are counted is less than negative 2.054, which is on the left hand side. Okay, this shaded region. Okay, now we will follow with the calculation right now. I will do it next to it. So now my calculation, it will be x bar minus mu over sigma over square root n. Okay, so now my x bar is going to be 9.8, because it's mentioned here, the mean of 100 worms. So 9.8 minus the mu at the H naught. So 9.8 minus the mu at the H naught is 10.3 over sigma is given, standard deviation 2.6. Then divided by square root 100. Okay, so from here you will be getting negative 1.92 equal to 3 significant figures. So negative 1.92, let me mark it on the graph, which is before negative 2.054. Alright, so from here our conclusion is, since the calculated value is greater than negative 2.054, then the decision is do not reject H naught, or you may say accept H naught, right? So do not reject H naught. So the conclusion is going to be based on the mean length. So I will say there is insufficient evidence to conclude that the mean length, okay, or as I said, the population mean length, right? The mean length has decreased, right? So that's the solution for question 3. Sorry, that's the solution for question 2. Okay, now question 3. 1.6% of adults in a certain town ride a bicycle. A random sample of 200 adults from this town is selected. A. Use a suitable approximating distribution to find the probability that more than 3 of these adults ride a bicycle. So from here, since you are considering 200 adults, so your n is 200, the p is 1.6%, so it means that it will be 1.6 divided by 100. So I will get 0.016. Right, so from here, it is basically binomial distributed. D, n is 200, p is 0.016. And then now, since your n is large, which is 200, then we need to approximate. Now we need to count what is your NP. 200 times 0.016, it will be 3.2. Okay, then from here we will notice that NP is less than 5. So when it is less than 5, we are going to approximate using Poisson distribution. Okay, therefore, let W be Poisson distribution with lambda 3.2, because lambda is the mean and also the variance, right? Okay, hang on. Okay, so now we need to count the probability that more than 3 ride a bicycle, more than 3 of the adults. So it means that P X more than 3. So when more than 3 means that now P W more than 3. Okay, because binomial and Poisson are both discrete random variables. So from here, I will just write this is 1 minus P less equals to PW less equals to 3. So when P less equals to 3 means that it will be 0 until 3. So I have to count all these probabilities. Alright, so now for information, when it is Poisson distributed, let's say x is Poisson lambda, so your Px equals to small x is going to be e minus lambda x over x factorial. So our variable is the x, means that e minus lambda is a constant. which means for all these probabilities, PW0 equals to 0 until PW equals to 3, I can factorize the exponential. So 1 minus E negative 3.2. Then when W equals to 0, so for any degree 0, it will be 1. And then 0 factorial is 1 as well. So I will write 1 for the first probability, right, after you have factorized the exponential. Then the next one is going to be 3.2 power 1 over 1 factorial. So you can just write 3.2. And the next is going to be 3.2 squared over 2 factorial. And then the next one is 3.2 cubed over 3 factorial. Right? So now from here, when you calculate the values, it's going to be 1 minus 0.6025, and now you will get 0.398, correct, to 3 significant figures. So that's the solution for the A. Now for parts B, justifying your approximating distribution. So the reasons is because the n is 200, which is greater than 50, and the NP is 3.2, which is less than 5. Okay, so these are the two reasons for you to approximate the distribution using Poisson. Okay, now question 4. The number of faults in cloth made on a certain machine has Poisson distributed, or has a Poisson distribution with mean 2.4 per 10 meter squares. An adjustment is made to the machine. It is required to test at 5% significant level whether the mean number of faults has decreased. A randomly selected 30 meter squares of cloth is checked and the number of faults is found. A. State suitable null and alternative hypothesis for the test. Alright, so when you look at the question here, 2.4 per 10 meter squares. And then now you are using 30 meter squares, means that now I need to times 3 to 2.4, right? Because this is triple of 10 meter squares, right? So now I will say 2.4 multiplied by 3 is going to be 7.2. Then our H naught is lambda equals to 7.2 because it's going to be Poisson distributed. And then the H1 is lambda because now you need to check whether the mean number has decreased. So it will be lambda less than 7.2. Right? So that's the solution for A. Now B, find the probability of a type 1 error. So probability of type 1 error, it is defined as probability that we reject H naught given that H naught is true. Okay, so by looking at the H naught, which is 7.2, now we need to find out what is the condition for you to reject the H naught. Right? So then don't forget that alpha is 5%. Right? So I will write down here with alpha equals to 0.05. So we reject H naught. Okay, so just a remark here. Reject H naught if the probability that x less equals to small x is less than 0.05. Okay, so now we need to find what is this probability. So now, right, so I will say this is x is Poisson 7.2 when the H naught is true, right? So now I will start with x less equals to 2. So when x less equals to 2, same as just now, x is Poisson lambda. Then the px equals to small x is going to be e minus lambda x over x factorial. This is the formula for Poisson distribution. So now I will just write this is px equals to 0 plus px equals to 1 plus px equals to 2. Okay, so now I will factorize the exponential negative 7.2. So the first term is always 1, then plus, second term is going to be the lambda value, Then the Ps equals to 2 is 7.2 squared over 2 factorial. So from here, you will get 0.02547. Okay, or I will just say it is 0.0255. Correct to three significant figures. Now I need to check the next one because this is less than 0.05, less than our alpha. So what happened to the next x, which means x less equals to 3. So when px less equals to 3, I will say that it is px less equals to 2 plus px equals to 3. Okay, so we do not need to recalculate the first three probabilities. So now from here, okay, so I will write this is okay. Now for your information, if you need the previous calculation for next calculation, so better to leave your answer to 4 significant figures first for the previous calculation. So the previous calculation I will need to write it is 0.02547. Then it's the same as 0.0255, which is less than 0.05. Okay, then for the next calculation, I'm going to use the first value, so which is 0.02547 plus Ps equals to 3 is E negative 7.2 bracket 7.2 cube over 3 factorial. Alright, so when you count this value, it's going to be 0.0719. And now this 0.0719 is basically more than 0.05. Alright, so when it is more than 0.05 means that it is not reject H0. Okay, because we reject H0 when the probability is less than 0.05. So from here, P type 1 error is going to be probability of reject H0. So which means our probability is the one which is less than 0.05, which means this 0.0255 is our type 1 error probability. So P type 1 error is 0.0255. Okay, so this is how we solve this question 4. Right? So now, next part, exactly 3 faults are found in the randomly selected 30 meter squares of cloth. C carry out the test at 5% sequence level. So since this is 30 meter squares, means that our H0 H1 remains the same because this H0 H1 is for 30 meter squares, right? So now I will rewrite our H0 H1. The alpha is 0.05. Okay, then from the previous calculation, then it is exactly 3 faults are found. So we have done the calculation here, which is 0.0719. Okay, so from B, Px less equals to 3 is 0.0719. Right? And this probability is greater than 0.05. So when it is greater than 0.05, based on the calculation of the previous conclusion, we know that when it is greater than 0.05, we do not reach a H0. Okay, so now we just write down the decision. Since Px less equals to 3 is greater than alpha, right? That means we do not reach a H0. So now let's go back to the objective of this test. You want to test whether the mean has been decreased, right? So, and now from here we know that we do not reject H0. We do not reject H0 means that we don't have enough evidence to conclude the H1. So the conclusion is going to be there is insufficient evidence to conclude that the mean number of faults has decreased. Right? So that's the solution of this part. Now, later a similar test was carried out at 5% significant level using another randomly selected 30 meters squared of cloth. D, given that the number of faults actually has a Poisson distribution with mean 0.5 per meter squared. Find a probability of a type 2 error. Okay, so now, again, this is for 30 meter squares, and now you are given 0.5 per 10 meter squares. So now, 0.5 needs to be times 3, it will be 1.5. So it means that for 30 meter squared, we will expect 1.5 faults, right? So now, alpha equals to 0.05, and probability of type 2 error is probability such that we do not reject H0, probability of do not reject H0, given that your H0 is false. So when the H0 is false, right, that's why now the original H0 was 7.2, okay, so that's why now you are given is actually 1.5. So this means do not reject H0, given that your X is Poisson 1.5. Okay, that's the correct H0, right, because your H0 is false. So now from here, we know that do not reject H0 based on the previous part. Okay, do not reject H0. Now you see here, reject H0 when it is less than equals to 2. Means that when do not reject H0, it will be greater than 2. Okay, so now I will say this is same as probability of X is greater than 2. So when greater than 2, now let's look at here. For the Poisson distribution, your X values will be 0, 1, 2, 3, 4, and so on, right, until infinity. So now when greater than 2 means that it starts from 3. Could be 3, 4, and so on. So now I will say that it will be 1, total probabilities, minus 0, 1, and 2. Alright, so it will be 1 minus b, x less equals to 2. So when x less equals to 2, it will be same as 1 minus px equals to 0, 1, and 2. So I will just direct write it here to save the steps. So px equals to 0, then plus px equals to 1, then plus px equals to 2, provided it is Poisson distributed. So now the formula is going to be e negative 1.5. Then when px equals to 0, after you have factorized the exponential, left 1. When px equals to 1, after you have factorized the exponential, it will be 1.5. Then the next one is going to be 1.5 squared over 2 factorial. So now when you calculate this, it will be 1 minus 0.8088. And now, leave your answer equal to 3 significant figures is going to be 0.191. Okay, so this is how we count the type 2 error probability. Okay, now let's move on to the next question, number 5. X is a random variable with distribution binomial, n is 10, p is 0.2. A random sample of 160 values of x is taken. Find the approximate distribution of the sample mean, including the values of the parameters. So from here, your x initially mean equals to 10 times 0.2. That means it is 2. And then the variance is going to be NPQ. So 10 times 0.2 times 0.8. Because n is 10, p is 0.2. So from here, you will be getting 1.6. Okay, but then you are given 100 sample size. Alright, the sample size is 100. So now you need to count the distribution, or you need to find the distribution of the sample mean. So now sample mean, okay, it will be normally distributed. with mean 2, and then the variance is going to be 1.6 divided by 160. Okay, which means this is x bar is normally distributed with mean 2. Standard deviation is going to be, variance is going to be 0.01. Okay, so that is the approximating distribution of the sample mean. Right, now hence, find the probability that the sample mean is less than 1.8. So from here, I will just write P x bar less than 1.8. Okay, so we need to standardize it. So z less than 1.8 minus the mean, which is 2, over square root of 0.01. Right, so when you calculate this value, it will be pz less than -2. So when pz less than -2, I will draw the graph. My critical value is at -2, and the region is towards left hand side because of less than. So based on this, we know that we need to flip the region to the right side so that the critical value is positive, and then the region will be upper region. Okay, so from this graph, I will know that the existing probability becomes pz less than 2. So when you need to count pz less than 2, pz more than 2, but you need to count that green region is going to be total probabilities, which is 1, minus pz less than 2, okay, minus all this, the regions towards the left hand side. So I will write this is 1 minus pz less than 2. And now from the table, pz less than 2 is going to be 0.9772. And now, when we round up, when we calculate this value, it will be 0.0288. Okay, so this is the answer correct to 3 significant figures. Right, so now the next question is number 6. The methods in grams of a small and large bags of flour has distributions normally distributed 510 for the mean and variance is 100. This is for small bag, alright? And for the large bag, it will be normally distributed with the mean 1015 and the variance is 324, right? So Andrew selects 4 small bags of flour and 2 large bags of flour as random. So now A, find the probability that the total mass of these 6 bags of flour is less than 4130. Okay, so now I will write the X is small, right? X means small, the large means Y. So your X is, or probably I will just write S. The S is small, this is S, the large is L. So S is normally distributed 510, 100. The last one is normally distributed with mean 1015, variance is 324. Okay, now it's mentioned total of 6 bags. So 4 small. So 4 small plus 2 large. And let this be total T. So now expected T is expected 4S plus 2L, which means this is 4 expected S plus 2 expected L, which is the mean, right? The ES and EL are the mean for S and L. So 4 times 510 plus 2 times 1015 is going to be 4070. Now, for the variance of total, this is going to be variance of 4S plus 2L. So since these 4 are 4 bags, right, and then 2 are 2 large bags, means that it's like you get the summation of 4 small bags and the summation of 2 large bags. So for your variance, it will be just 4 variance S plus 2 variance L, which is not the multiplication, it's just an addition. So from here, it's going to be 4 times 100 plus 2 times 324. So at last, you will be getting 1048. Okay, so now we need to get the total. Okay, so now I will say my T is normally distributed. The mean is 4074. Then the variance is 1048. So now probability that the total is less than 4130. So PT less than 4130. So now we need to standardize it. So it will be Z less than 4130 minus 4070 over square root of 1048. Okay, then here is going to be PZ less than 1.853. And now, when you refer to the graph, the critical value is positive 1.853 and your region is less than. That means the region now is exactly the same as the region in the table. Therefore, we can just direct read the answer from the table and you will get 0.968. So that's the solution of this question. Okay, now next B. Find the probability that the total mass of 4 small bags is more than the total mass of 2 large bags. So now you need to count 4 small is more than 2 large. This is what you need to count. So it means that now I need to get P4S minus 2L more than 0. So which means I need to recalculate my mean and variance and get the new distribution. Okay, so I will let y equals to 4s minus 2l. So now I need to get my EY. EY is going to be 4es minus 2el. So now replace the values. Expected S means that the mean of the S. So the mean of the S is 510 and then for the L is 1015. So 510, 1015. So then from here you will get 10. Okay, so variance Y, it will be 4 variance Y plus. Okay, so be careful with this. So maybe I just show you step by step. So here is going to be variance 4s minus 2l. So it will be 4 variance s plus 2 variance l. Okay, due to this reason. So for information, EAX plus minus BY is going to be AEX plus minus BEY. But for variance of AX plus minus BY is going to be, depends on the A and B. If it is multiplication, then it will be squared for both. Alright, so if it is addition, then it will be just A and B. So now, for your information, for variance, even though this is plus minus, but here end up with plus. Okay, that's why in my working here, I use plus. So please take note on this. Variance S is 100. The variance for Y is 3 to 4. So 100, 3 to 4. So here is going to be 1048. That is your variance Y. Okay, so now I will say that my Y is basically normally distributed. The mean is 10. The variance is 1048. And now I need to count P, Y is more than 0. Okay, based on the previous. Right? So now when Py more than 0 and your Y is normally distributed means that now we need to standardize. So Pz more than 0 minus 10 over square root of 1048. So then you will get Pz more than negative 0.309. And now I will sketch a graph. Negative 0.309 is on the left hand side and then it is greater than. So greater than means the region towards the left hand side. So in this case, we need to flip. Okay, because the region is towards the right hand side and basically the main reason is because of your critical value is negative. So I flip it, it will be positive, and then at the same time I also flip this blue region, it will be the green region over here. So based on the graph, it becomes PZ less than 0.309. Okay, once you get this probability, you can just read the table because it is the same region as in the table. So I will get 0.6213 and you round up to 3 significant figures. So you'll be getting 0.621. So that's the probability of this question. Right. So now for question 7. The diagram shows the graph of PDF, probability density function f, of a random variable x, which takes values between -3 and 2 only. So that's why here -3 and 2. Okay, after that, 0, flat. Then now, given that the graph is symmetrical about the line x equals to -0.5, that means, right, it is symmetrical at this point. And given that px less than 0 equals to p. Okay, so here, this is p, the probability. Now, you need to find px between -1 and 0. So, for your information, right, since it is symmetrical, the graph is symmetrical at x equals to 0.5. So, the total region here on the left-hand side is going to be 0.5 because the total area of the graph will be 1. Okay, so from here, basically I would say px, because it's mentioned x here, px between -3 and -0.5 is going to be 0.5, okay, which is the green region. And then now you need to count the probability that x between -1 and 0. -1 and 0, which means it's here. Okay, and we know that since it is symmetrical at -0.5, means that here from -0.5 to 0, it will be 0.5 units. And then from -0.5 to -1, it will be 0.5 units, which means it is symmetrical, right? So I need to find the region between the x between -0.5 and 0. After that, I flip, I times 2. That will be the probability that you need to find. So now I will say that the p -1 to x, x between -1 and 0 is going to be double of probability. It is between -0.5 and 0. Okay, so now probability of x between -0.5 and 0, which is this part, is going to be the whole probability, which is a p, minus 0.5. Okay, minus the green color. That will be the region that we need to count. So here is going to be probability of x less than 0 minus p x between 0, I would say is between -3 and -0.5. Okay, which means the green region. So here, right? So when you minus the p minus the green region is going to be the region in between 0.5, -0.5 and 0. So obviously here px less than 0 is going to be p. Then px between -3 and -0.5 is going to be 0.5. Okay, which is a green color. So I will write minus 0.5. So now when you do expansion, it will be 2p minus 1. So that is the probability for x between -1 and 0. Right? So now for part B, is now given that the probability density function shown in the diagram is fx equals to a minus b multiplied by x squared plus x for x between minus 3 and 2. And for other x, it will be 0, where a and b are positive constants. So show that 30a minus 55b equals to 6. So to show this, I will use integration, right? Because we know that if the function is defined for x from minus 3 and 2, okay, between minus 3 and 2 means that the integration from minus 3 to 2 for the fx it must be 1. That is the properties of the probabilities. So now integrate from minus 3 to 2 fx dx is 1, which is the total properties equals to 1. So now I will write minus 3 to 2 a minus b bracket x squared plus x dx equals to 1. So when we integrate, the first term becomes ax. Now the b multiplied by x squared, I will write minus bx cubed over 3. Okay, I put the b outside. Then the plus x becomes plus x squared over 2. Then the limits from minus 3 to 2 and equals to 1. So now replace the x by 2 first, because the 2 is the upper limit. So I will get 2a minus b bracket 2 cubed is 8. Then over 3 plus 2 squared over 2 is going to be 4 over 2. I'm getting 2. Then minus when the x equals to minus 3. Okay, so substitute x equals to minus 3 here. I'll get minus 3a minus b bracket minus 3. When you sub into here, the cube, I will get negative 27. Negative 27 divided by 3 is negative 9. Then plus square of minus 3, which is the next term. Square of minus 3 is 9. So plus 9 over 2. That equals to 1. Okay, so open all the brackets. I will get 2a. Now 8 over 3 plus 2 is going to be 14 over 3. Then multiply by minus b. At last, it will be negative 14 over 3b. This minus multiplied with the whole bracket, it will be plus 3a. And then minus 9, okay, here. Minus 9 plus 9 over 2 is going to be 9 over 2. Okay. Minus 9 over 2, it is minus 9 over 2 here. Then the minus multiplied by minus b is going to be plus b. So that's why you'll be getting negative 9 over 2b. That equals to 1. Alright, and based on the question, you need to show 30a. So now, 2a plus 3a, first and third term plus together, it will be 5a. Then the b, it will be negative 55 over 6. Then equals to 1. So from here, at last, we just multiply by 6 for the whole equation, and you will get 30a minus 55b equals to 6. So that is how we show the equation. Alright, so the first part is done. Now, part 2, by substituting a suitable value of x into fx, find another equation relating a and b. Okay, so this is the first part. And hence means use the equation, which is our first part, determine the values of a and b. So here we have to solve two parts. This is the second part. Now, to get another equation relating a and b, let's go back to the function. Okay, just now we have used minus 3 and 2, right? You integrate for this whole interval, and the probability and the integration will be 1, which is the total probabilities. And now to form another equation, we can use otherwise. Alright, so it means that other values. Now, for your information, if it is less equals to 2, you will get the function. But if it's greater than 2, right, or it is less than minus 3, because here is greater and equals to minus 3. So if it is greater than minus 3, you will get 0. Alright, so now from here, I will say that my f2 equals to 0, because for probability density function, which is the continuous random variable, equal or not equal sign will be the same. So from here, I will say F2 is 0. Okay, so now to solve that question, I will write F2 equals to 0. So 0 equals to, refer back to your fx. Your fx is a minus b bracket x squared plus x. So I will write a minus b bracket x squared. My x becomes 2 now. 2 squared plus 2. So from here, 0 equals to 2 squared is 4. 4 plus 2, 6. That means a minus 6b. Okay, this is the equation. Alright, so now, done the first part. Then hence determine the values of a and b. So I will let 0 equals to a minus 6b be the first equation. Now my second equation is going to be the previous. This 30a minus 55b equals to 6. It will be my second equation. So 30a minus 55b equals to 6. Now to solve these two equations, right, I will use substitution method. So from the first, my a is going to be 6b. And let this be the third equation. Now I substituted into second equation. So 30a, my a is 6b, minus 55b equals to 6. So from here, 180b minus 55b equals to 6. Therefore, you will get 125b equals to 6. Then hence your b is going to be 6 over 125. Okay, once you have found the b, substitute back into the third equation. So from third equation, my a is 6 times b. So you will be getting 36 over 125. Alright, so that is how I solve the question part 2. Okay, so that's all for the paper, and we have come to the end of the video as well. Alright, thank you for watching. If you enjoy watching my video, please subscribe to my channel and stay tuned for more upcoming videos. Alright, thank you. Bye.